Okay, so figured that it would probably be helpful if we had a couple of practice problems going over the quiz 4. So for this one, I'm going to do the quiz 4B, and then we'll record quiz 4A, get that uploaded as well. But looking this one over, this quiz covers material up through lofts. So we do have a loft that's going to be involved here. None of the loft questions are going to be particularly complex. It's just going to be standard, like one profile to another profile, and if there's anything tricky going on, it'll be in a note. So here we do have a note specifying that the start and end conditions are set as normal to profile with a length of 1. So, all that said, let's get this problem started. So we're going to open up a new part file. This one's going to be in millimeters. So once we get our file open, mmgs, and then let's take a look and see where we should start. So this one we do see has a sort of hollowness to it. So we do have some aspect of our object is going to be hollowed out. And then we also see that we've got these sort of crimps on the back. We've got this sort of toothpaste spiral coming out on the front. We've got the main tube of the toothpaste. That one is hollow, so that's going to need to happen before our shell feature. We've also got the front bit here. That's going to need to happen before our shell feature. See the hidden lines on the inside there. Whereas the toothpaste and the sort of crown on the end, those are solid. So those are going to need to happen after the shell feature. And then similarly, can't really zoom in all that well on this. Let's get a snip going. Helps if I can actually see the whole picture. There we go. So the 0.5 dimension here, that goes to the inside of that. So that tells us that when we're creating the sweep for the toothpaste itself, that's going to need to happen, or need to sort of go into the shell a little bit. So, all that said, let's get started. So with our loft feature, we see that we've got a circle on one end and a sort of rectangle on the other. So based on our dimensioning, we see that it's 6 units from left to right and 0.1 unit thickness. And then for the circle, our dimension for that is over here, diameter of 5. And then we're probably going to do some kind of revolve to get sort of the conic piece and the cylinder. And then for our curl, we can probably do a sweep to sort of get that down, and then probably a dome or revolve to get the sort of end cap on it there. So, getting started, can create a new sketch. This one we're going to do the loft, and let's set it so that we're doing the circle first. And that's going to be parallel to the front plane, so the front plane. And for that, we can draw in our circle. So one standard rule with lofts is we want to make sure that each profile has the same number of edges as the other profiles in the loft, and that gives us a bit more control over it. So we can see that we've got these kind of guidelines sort of showing where it splits off. So this quarter of the circle matches up with the vertical bit on the right end of the rectangle. So in order to do that, we can use the segment tool. So that's going to be under Tools, Sketch Tools, got Split, and Segment. Segment's nifty because that adds in an equals relation for everything, so then we don't need to worry about it too much. But you can also use Split to sort of manually cut it up as needed. So we'll segment our arc like that. There we go. And now we... Oh, oops. Of course, fell for the standard. You can also just search it up. This, you want to set it to sketch segments, because for whatever reason, the default option for segment is to not cut it into segments. I don't know either. It bugs me and catches me every now and then as well. But segment, there we go. So now we see that we've got our arc and it's actually split up into these sort of 4 quadrants. So now we can get this thing defined. We know it's got a diameter of 5 units, so we'll smart dimension that. It's going to be a diameter of 5, so be a radius of 2.5. However, we can't leave it as a radius, and this would be counted as calculating a dimension. So once we've got it down, we can right-click on the dimension and set to display as diameter. So now it's showing it with a diameter of 5 units. We're still underdefined though, so we've got these points. It is cut up into these chunks, but they're not set for its rotation, so currently it can spin freely. In order to take care of that, we can just grab 2 adjacent points, so these 2 are part of the same arc, and based on what we see in our isometric and in our top view, it looks like these arcs kind of stay quartered. And we've got sort of 1 quarter on the top, quarter on the right, quarter on the left, and then probably a quarter on the bottom as well. And from all of that, it looks like it's pretty symmetrical with itself, and that it's got points sort of up. Sort of, what time would that be on a clock? Sort of at like the 1:30 mark. So for that, we can just grab these 2 points, and if we set them to be vertical with each other, that sets our rotation so that our quadrants are sort of in the northeast, southwest portions of the compass. Cool. So there's our first sketch. A loft, however, usually needs more than just one. So at this point, we now need another sketch that's 15 units behind it. So to get that, we're going to need an offset reference plane to do that sketch on. So on our reference geometry, create a new plane. This one uses our front plane as a reference, and we see that it's 15 units. So we'll plug in 15 there, flip it so it's behind our circle, and check mark. So far we've used the 15, we've used the diameter of 5. Now we've got our rectangle. So we're going to create a new sketch on this one. And for that, we can do a center rectangle. So this one's in the drop-down next to the rectangle tool, center rectangle. From the information that we're given, we don't really have anything implying that it wouldn't sort of keep this level of symmetry to it. So we can pretty much assume that the rectangle is going to be centered at the same point as the circle. So from that point there, drawing it out, then our rectangle we know has a width of 6 units based on the dimension in the top view, and a height of 0.1 unit based on the dimension in the detail view. Cool. So that gets us set up there. Exit sketch, and then we can do our loft. Loft works best if you select sort of the edges that connect together. So this top quarter of our arc goes to the top edge of our rectangle in the back. And got it a little twisted, so if we just pop that over, there we go. So this looks mostly like what we're going for, but we do still have our note, and this one's telling us that the start and end conditions are normal to profile with a length of 1. So those are under the start and end constraints. Start, normal to profile, unit 1 there, and end, normal to profile, unit of 1 there. That, take a look at our right view, looks a lot closer to what we see in our section view. Check mark. Alright, next up we've got the little cone and cylinder. So for those, we see the profile pretty good in the top view, so I'm going to use the top plane as our sketch plane there. And then we want an axis that lines up with the axis of our cylinders. So vertical, straight down from our origin, and then we can draw in our lines. So for that, so it goes over, goes up, and then connects in there. So that actually gives us our outline. However, we do still need to complete our loop. So from that connection point back to our origin and closing the loop. Now we can dimension it. So we know that the cylinder at the end is 1 unit in length based on this dimension here. We also know that the cone has a sort of depth of 1.5, so for that we can dimension our diagonal, make sure that we're dimensioning the height of it, and that'll be 1.5. And then we've got a diameter of 1.5 as well, so we can go from the point to our axis, over to the other side, 1.5. Cool. So that takes care of that. Revolve boss base, and check mark. Cool. So now we've got that all sorted, and we can go about creating our shell feature. None of the rest of this is going to be hollowed out from the looks of it, so we're all good. And that front. See, our shell thickness is 0.1 millimeters, so shell feature 0.1. Set it to show preview so we can see what we're doing. For this one, it does look like the center, the sweep for our toothpaste itself, that sort of starts in a little bit and then continues all the way throughout. So if we want to, we could get the surface removed on the end here, but because the material is going to be going through there regardless, it isn't going to end up being necessary. So we can just leave this as is and check mark. Cool. Alright, next up, let's do the toothpaste itself. Makes sense. So for that, I believe a sweep would probably be the easiest tool. So on that one, we see that we've got our sweep path sort of follows from there, and this is all visible on the top plane. So we're going to create a new sketch on the top plane yet again, and then we can go about drawing in our curve. So we'll just draw it out in space first, just so that we don't have to worry too much about positioning it. Looks like it goes straight down, then we've got a 3/4 arc here. So in order to get that dimensioned or defined properly, we can end up taking the end point of the arc, and that looks vertically aligned with the center mark of it. So those 2 points, vertical. Nice. Then we can start positioning it. So the central axis remains consistent as we continue along. So we can just grab our edge, grab our center mark, or origin, sorry, and dimension, or concentric those together. Then we can go about throwing some more numbers. So we know the arc has a radius of 3 units. We know that the start of the toothpaste, based on our section view over here, so the end of this is 0.5 in from the end of the tube. So 0.5. We know the long bit of the toothpaste goes 6 units from the end of the tube. So from that edge to the point is 6 units. And yeah, that gets our sketch all nicely defined. Main trick with this is just to pay very close attention to where our dimensions are going. So the 6 units that we have in our drawing is explicitly going from the boundary, not from the start of the line. So we want to make sure that we're being careful to pick the right things when we're setting up our dimensions. We've used the 0.5, we've used the R3. Cool. So now we can pop over to features, swept boss base. Because this is a circle, or because the sweep is using a circle as its profile, we don't need to explicitly draw in the profile for it. But the sweep tool itself has a circular profile option, so we can use that to save ourselves the time and decrease the risk of accidentally mixing something up. So for our circle itself, we see that it has a diameter of 1.3 based on our front view. And all in all, that looks pretty much like what we're going for. Check mark. So next up, we've got this little portion of our object over here. You could do this either as a dome or as a revolve. Let's actually try it with the dome. So dome feature, I don't really like it a whole ton just because it doesn't give you that much control over the geometry, but it is pretty good at making nice smooth shapes. So for that, if we select that surface, it kind of inflates it out. This shows that it has sort of a width, in this case, of 1.25, so we'll plug that in here. But this does not look like the geometry that we've got, so that's probably going to end up being an elliptical dome. So, with modern problem design that I like to use, I would have a note specifying that it's elliptical dome, but this is a bit of an older problem, so it hasn't been updated. But this looks like what we wanted to go for, so that is one way to create that geometry. Another method would be to do a revolve, because this one is based on sort of that circular end surface. So on our top plane, we create a center line from the middle of that straight outwards. It's going to be horizontal. Then we can use a partial ellipse centered there, goes out to there, and then to there, and then it'll cap back off. Other option would be if you do a full ellipse and then use the trim tool to get rid of the excess. So we've got that. We can close the loop. And this is still going to need to be defined as 1.25 for the width. So from that point to that point, 1.25. Then from there, revolve boss base and checkmark. Cool. Two ways to make the same thing. So it depends on your idiosyncrasies, I suppose. But you can pick the one that you like. To avoid repeating dimensions, we'll make sure that we only have one of them and delete the other, so we don't want to leave anything just suppressed if we're not using it, because that still does include the dimensions that were used in it. So that could lead to some confusion when you go back in and try to make changes or edits. Alright, so the last bit that we've got is this little pattern on the back of our tube. And for that, we've got these little rectangular cutouts, and it looks like we've got 10 of them. So let's begin by creating one of them, and then it looks like it's probably going to be a pattern just to get the others, because trying to do this manually would be rather tedious. So in this case, we can pick one to start with, and then pattern out from there. Pattern works best if you choose one of the instances that's on an extreme, so here probably just picking this leftmost notch is going to be the easiest, and then we can pattern it with that 0.6 spacing to get over to the other side. So that little cutout looks like it's on the top, or it's visible on the top plane, and it's dimensioned in the top, or in a detail view taken from the top plane, so that seems reasonable. Your top view. And for this, looks like it's just a little rectangular cutout. So we'll open up just the regular rectangle tool, and it's going to be placed somewhere around there. And for this one, we see that they have a width of 0.2. So dimensioning the width, 0.2. And it has a height or depth of 0.3. So dimensioning this one as 0.3. Then we've got our position for it. So we see that in that view, the left edge of it is 2.8 units in, or 2.8 units to the left of our sort of center line. Center line ends up passing through our origin, so we'll grab the origin as one side, our edge is the other, and that dimension is 2.8. Cool. Features, extrude cut. And this, we want to make sure that it cuts through everything. And also, just because of where we ended up with our plane, we want it to be through both, so that it cuts through both the top and bottom of it to make it so that the notch is actually visible. Check mark. Otherwise, it would just be a little ridge on the underside, and that doesn't quite have the same effect. But we've got that there, and we can linear pattern. For these ones, we've got our features and faces. We're patterning that. We want them patterned horizontally, so I'm just going to pick one of the edges here. That ought to work out just fine. We know the spacing is 0.6 units, and we know there are 10 of them. preview looks pretty good. Check mark. Yeah. That looks about right. Control 7, double check our orientation. We match up pretty good. And I would say that looks pretty spot on. Awesome. So, hopefully that was helpful. Feel free to reach out if you have any questions. Otherwise, best of luck on the quiz.